Hello, Justin here. For the last couple of months, I've been developing a pair of tools to be used for developing Commander X16 games. More specifically, they're for developing the types of file formats needed to be imported into the VRAM of the VERA chip. The first one here is a GIMP plugin so that I can draw tile sets and bitmaps directly in the GIMP and export them into a file format that can be loaded up by the Commander X16 directly into the VRAM of the VERA. This goes a little bit beyond what the GIMP can normally do when it comes to raw formats and index mode, where you'd normally have to run it through a Python script to get it in the correct format. This does it automatically from the GIMP. Furthermore, it can also be called from interactive mode so that you can call the GIMP at a command line and build it into a Makefile. You can kind of see that happening down here in the GIF that I have on my GitHub page. The second tool has to do with creating the tile maps. So there's a popular application out there called Tiled, which is used for creating tile maps for video games. The problem is I couldn't find any way to tie that directly into the file format that the VERA needs without writing one myself. So that's what I did. And what I came up with is a command line utility called TMX to VERA. And the point behind this one is that you're able to use the tiled application to simply draw onto a map, as you can kind of see happening on the GIF on my GitHub page here, and save it out. And then you run the command line utility, again from a Makefile, and it will extract that layer and put it into the tile map for the Commander X16. Furthermore, using some advanced features of Tiled, you can get it to export collision maps so that your entire map can have a collision map, as well as interaction tiles and a few other things. It's pretty cool, and it allows you to use some modern tools like Tiled for developing Commander X16 games. Anyways, I created a quick demo video that's a start to finish project, really simple example project, and I would like to show that to you now. First, I'll create a new directory to put my project in. This directory is completely empty. Using a skeleton file as a template, I create a new Commander X16 project makefile. I give my program a name, and I rename the makefile from the name of the skeleton to just makefile. I then use another skeleton file to generate the main assembly code for a Commander X16 program. I then use two more skeleton templates to create X16 and VERA include files that define useful memory locations. With these template files all created, I can now make and run my Commander X16 application, which currently doesn't do anything. The tools I am demonstrating output binary files that are to be loaded directly into the VERA's VRAM. In order to do this, my application is going to need to be encoded with the names of these files. I have a snippet that will generate the CA65 macro that encodes the file name into the output binary. My demo application will use a single tile layer using my own tiles, my own custom palette, and my own tile map. These three resources are what my custom tools are going to generate for me, so I'm going to use my snippet to define all three of them. With the file names defined, I now need to define the VRAM locations where these files will be loaded into. My tiles will be loaded at VRAM address 0, and because this is only a demo application, I'm just going to leave 16K before defining my tile map. Remember that VRAM addresses are 20 bits long, so you're going to be using 5 nibbles. The palette address on the VERA is fixed at 1FA00. With the file names and VRAM addresses defined, it's time to initialize my video mode. I'm going to use a snippet that initializes the video mode to simply use layer 0 and nothing else. For most games, you're going to want to scale up the pixel size. I'm going to go with a 2x scale using another snippet. I need to set my layer 0 mode, and I have plenty of snippets defined to help me do this. I'm going to choose one that uses 8 bits per pixel and 32 tiles by 32 tiles. I consider this coding on easy mode, because I don't have to worry about palette offsets, and yet I still have access to all the colors of the palette. I then need to set layer 0's tile base. When I do this, I'm also going to define the tile size, which I'll choose 16 by 16. I'll use the VRAM address I defined earlier. The final piece of VERA configuration is setting the layer 0 map base to the VRAM address I defined earlier. Now it's time to use the file names that I defined earlier and to load up the contents of those files into the VRAM addresses that I also defined. Using snippets makes all these tasks much easier, although keep in mind a snippet really isn't much different than an assembly macro. The only difference is a snippet expands inside your editor, while a macro will expand in the assembler and you'll never see it. For the purposes of this demo, I'm using snippets. With the files loaded into VRAM, the assembly coding part of this demonstration is complete. I can run the application now, but since the resource files don't exist, all that gets loaded into VRAM is garbage, and that's what you see on the screen. Finally, it's time to start showing off the tools that I'm making this demonstration for. The first one is a VERA export plugin for the GIMP. So I'm going to fire up the GIMP and I'm going to create a really simple tile set. As I defined in the code, I'm going to use 16 by 16 pixel tiles. So if I want 256 tiles in my tile set, I'm going to make my file size 256 by 256 pixels. Do the math, it works out. The first thing I like to do when I'm defining a tile set is to configure the grid of the image. I'm going to use dashed lines, I'm going to give it a middle of the road gray color, and I'm going to make it 16 by 16, my tile size. I also like to set my background to black, which will be used as a transparency color, and then I do all my work in an additional layer that I just named tiles. I'm going to create 3 terrain textures: water, dirt, and grass. Water is never going to touch grass, but dirt will touch both water and grass. Here I'm defining the tiles where water touches dirt. The reason I created my VERA export plugin for the GIMP was because I wanted to be able to do my tile sets and bitmaps inside of a professional level application like the GIMP. Others have taken advantage of the GIMP's ability to export raw indexed files, including palette files, and then run it through a custom script or something in order to turn it into a VERA-compatible format. While I like this approach, I wanted to be able to create my VERA-compatible binaries directly from the GIMP. I also created a couple of other useful features while doing this, but we'll get to those later. Because I'm going to use my own custom palette, I can choose whatever colors I want. I just have to make sure to not choose more than 255 of them. Remember that index 0 is always going to be used for the transparency color, so that's why I just kind of set it to black. GIMP will do this by default when you generate a palette. I like using the GIMP's ability to do rounded rectangle selections. I use this to draw the different parts of my tile map. Unfortunately, I have not figured out a key binding that can expand the rectangle arbitrarily in one direction or the other, so I'm just kind of doing that part manually. It's the most tedious part of this whole process. I found that when doing 16 by 16 tiles, it's nice to use 6 pixels and 10 pixels for the different terrain types. You just have to keep track of which one's which when you're defining the different tiles. In this case, I'm using 6 pixels for the dirt and 10 pixels for the water. Now that I've drawn my tiles for dirt on water, it's time to draw my tiles for grass on dirt. I start by making another 3 by 3 square with grass as the base and dirt in the middle. Again, dirt is going to be the 6 pixel terrain, and grass now is going to be the 10 pixel terrain. Again, I count off the pixels by hand with a mouse. If anyone has any better suggestions, please leave a comment. I save a little bit of time when I draw the dirt in the middle of the grass by simply drawing a squared rectangle from the center and then just seeing how large my selection is. In this case, I want it to be 12 by 12. In order to showcase a few more colors in my custom palette, I'm going to add some shading and some highlights to a couple of the terrain elements. In a real tile set, I would spend a lot more time in adding texture and other things to these, but this is just a demonstration. This is where using a custom palette comes in handy. If you're good with color theory, which I am not, you could select which colors are appropriate for both shading and highlights. Here, I'm doing my best, so anyone who knows color theory, please forgive me. I'm not going to add complete shading and highlighting to every edge. As I said, this is just a demonstration, and I'm really just adding the shading and highlighting so that I can have a more complete palette when I export. When I'm happy with the tile set, I'm going to save my GIMP project file in my projects directory. This file will actually be referenced by my Makefile so that in a later step, I can run my plugin as part of a build. I will need to switch the image mode to indexed. I could choose a predefined palette and it would try to do a best fit of my colors. In fact, I have the VERA palette defined in my version of the GIMP here. But instead, I'm going to generate a custom palette based on the colors I've actually decided on in my image. I can view my custom palette in the Color Map tab. GIMP has a Palette tab, but that's actually more of a color selector. The Color Map tab is what's actually used for an indexed mode image in the GIMP. Now it's finally time to run my custom export plugin. I simply export to a file name that ends in .bin. From there, my extension will take over and it'll start showing you the dialogues that I've defined that'll help you export tiles and bitmaps in the VERA compatible format. I wrote this plugin to use both interactive mode and non-interactive mode. This is interactive mode, but non-interactive mode is calling it from a script at the command line. This is going to be really useful for hooking this into our project's Makefile. I select 8 bits per pixel and 16 by 16 tiles. Additionally, I'm going to have the plugin write a tile set in the TSX format that can be read by the tiled application. I'll also export a bitmap file for that tile set to reference and a palette file that can be loaded directly into the VERA. The GIMP will put up the standard dialog for exporting a bitmap, and when I hit export, I should get all my files. If I go to my project directory, you can see that I've exported 4 files. The first is the tiles.bin file, which we reference in the code, and we're going to load directly into the VERA. Then there's the bitmap, there's a palette file that I'm going to have to rename, and then there's the tiles.bin.tsx file, which defines the tile set for the tiled application. Now I'm going to open tiled, which is what I'm going to use to create my tile map. I'm also going to use some advanced features of it, including turning my tile set into some predefined terrains. I opened the tile set file that was generated, and you can see the bitmap I generated right here on the screen. Now I can go over to the Terrain Sets tab, and I can define which parts of this tile set are dirt, water, and grass. This is an advanced feature of Tiled that'll make creating maps easy. I simply have to define which types of terrains I have, in this case dirt, grass, and water, and then I draw over them to tell Tiled which part is which. This initial setup of creating terrain sets saves you a lot of time when it comes to drawing your maps. You should go online and look up some tutorials on how to use tiled and terrain sets. It's pretty cool. One of the reasons I developed these tools was because I wanted to use the advanced features of Tiled. This really saves a lot of time when it comes to game development. I'm using what's called a mixed tile set, which is the most flexible type of tile set. You have to be really careful to define each part that is and is not part of your terrain, and you also have to make sure that when you're drawing your tile sets, that all the pieces line up. Once I've defined my terrain sets, I need to save the tile set file. Now I'm never going to want to export the tile set from GIMP again because it'll overwrite these terrain sets that I just created. Now it's time to create my map. Just like I used when I set the layer mode, I need to use 32 tiles by 32 tiles. And just like when I set the tile base, I need to choose 16 by 16 pixel tiles. I'm going to use the rectangle tool to just draw water all over my map. My map's essentially going to be a series of islands. Now I get to use the terrain set that I defined earlier. I select which terrain I want to draw. In this case, I'm going to draw grass. When I draw grass, it always draws dirt between the grass and the water, so it's an easy one to choose when my map's all water. Now I can just draw islands onto the screen, and Tiled will make sure that the tiles line up correctly. It's pretty cool. This is definitely one of the features that made writing the custom tools worth it. That and creating collision maps, which I may show in a later video. I saved the map file to the project directory, just like I did with my GIMP project file. This file too is going to be referenced from the Makefile and used by my custom export tool in order to create my VERA compatible map. From here on out, I'm going to treat my GIMP project file and my tile map file as sources that are used to build the resources that I need for my application to run. I go into my Makefile and I define the resources. These are the exact same file names that I encoded into my application earlier. Each one of these resources will have to have its own build target in my Makefile, but for now I want to make sure that the resources are all built and cleaned when they should be. I create a resources make target, and then I use that resources make target as a dependency of the run make target. After all, I can't run my application without its resources. I also create a clean resources make target, and then a clean all as a convenience to clean both the application and the resources. To build my tileset binary, I need to call the GIMP from non-interactive mode. This is a bit complicated, so I've created a snippet. I make one modification from what my snippet expands to, and that is to specify that I want the palette file to be exported as well. I do not have the TSX file set to be exported, however. I do not want to overwrite those terrain sets I created. I do export the bitmap because that'll allow the changes to be shown inside of Tiled whenever I'm editing that tile set and the terrain sets. My plugin exports the palette file using whatever name you give it for the main export plus .pal. I want to rename this, and I can do that using a trick of the Makefile. By creating a pal.bin make target that uses the tiles.bin as a dependency, I know that when tiles.bin is run, I will have tiles.bin.pal. So in this make target, all I have to do is rename it to pal.bin. The last resource to build is the tile map. I use my tmx to VERA command line utility to do this. Again, for ease of use, I have a snippet. I didn't name my layer correctly, so I'm going to go back into Tiled and make sure it's named Terrain, as I have specified here in the command line. Now, all I have to do is go to my command line and type make resources, and we should see these 3 resource files be built and named correctly. With this, my application is built, and all the resource files are available. I can run it. Now whenever I need to change a tile map, I just go into Tiled and I do my edits there. It's really convenient. All I need to do is save the TMX file, and my Makefile will recognize that it's changed and rebuild the appropriate resources. The same is true for editing my tiles. All I need to do is go into GIMP and save the GIMP project. From there, my Makefile will recognize that the GIMP project has changed, and it'll update the tiles and the palette accordingly. Because building the resources is a prerequisite of make run, that's all I have to do with the command line. Make run, and the resources automatically rebuild. This all makes for a really nice development flow. I just go into my text editor and I edit my code, such as making the screen scroll horizontally, and then I can just call make run from the key bindings I already have set up in Vim. Whether I'm editing code or resources, my workflow is still the same. I make the edits, I save the files, and I type make run, or just run it from my editor. I've included the links to my GitHub pages in the description, so feel free to download, install, and play around with it yourself. Thank you for watching.